So now come to question number 8, exercise 1, phase 2 ellipse. Find the conditions so that the line Lx plus My plus n is equal to 0 may be in normal to this ellipse. So first we know the standard form of ellipse normal. A square x upon x1 minus b square y upon y1 is equal to a square minus b square. This is the standard form of normal to this ellipse. Now this equation 9.1 and 9.2 represent the same line. One another method you can take in parametric form also. Then we have to eliminate the variable theta. That also will work out. So in that case, you can put x1 is equal to a cos theta, y1 is equal to b sin theta. So a square x, a cos theta, so it will cancel a square. Ax upon cos theta minus by upon sin theta is equal to a square minus b square. So a sec theta x minus b cosec theta y is equal to a square minus b square. So this is the normal third equation. So 1 and 3 represent same line. Both are the normal. So comparing the coefficient. So from here we will get L or a sec theta upon n is equal to minus b cosec theta upon m is equal to a square minus b square upon minus n. Transferring this term this side. So from here you can calculate sec theta is equal to n a square minus b square upon a n, and cosec theta minus minus will cancel is equal to m a square minus b square upon n b. Now reciprocate them, square and add. Then you must get answer. We have to eliminate from here theta. That will be the answer. Relationship I have to calculate basically. So cos theta is equal to a n upon l a square minus b square, and sin theta is equal to b n upon m into a square minus b square. Squaring and adding. So 1 is equal to a square n square upon n square a square minus b square whole square plus b square n square upon a square minus b square whole square. Multiply this side, m square will come here. Multiply this side. So a square minus b square whole square upon n square is equal to a square upon n square plus what is left here, b square upon m square. So this must be the relation. So this completes the question. Thank you.